Welcome to this installment of the GREET tutorial video series where we'll be discussing coproducts and how they're treated in GREET. First, we'll review some basic information about coproducts and what they are. We'll review the coproduct treatment methods of allocation and displacement. We'll open GREET and see where to find or edit coproducts. And finally, we'll look at process results for different coproduct treatment methods. In life cycle assessment, a product is a processed good or a service resulting from a process. And if that process happens to have more than one product, they're called coproducts. In GREET, there's always a main output that will be used downstream in the pathway, and all other products from a process besides the main output are referred to as coproducts. Coproducts can be defined in a process to more accurately depict all the input and output flows involved in creating the main product, and to measure any impacts or benefits that are a result of utilizing secondary products. For example, an oil refinery produces a number of valuable petroleum products from the material left over from making gasoline or diesel. Likewise, a byproduct of ethanol production is distillers' grains that can be used as animal feed. In both cases, there are multiple products from a single process. When a process has more than one output, either the total energy consumption and emissions have to be allocated among them, or the secondary products can displace other products within the system, thus decreasing overall energy and emissions for the process. The first method is called allocation. The second is called displacement. When using the allocation method, we have to choose some basis for allocation, like mass or energy, by which we'll divide and allocate energy use and emissions. For instance, if we use mass, we could allocate emissions to a coproduct based on an allocation factor, or the mass of the coproduct in relation to the total mass of all the other outputs. When using the displacement method, we identify another product or material that will be displaced by our coproduct. GREET then subtracts the energy and emissions that would have resulted from the displaced product. These energy and emissions act as a credit toward the energy and emissions of the process, reducing overall energy and emissions. Dealing with coproducts in life cycle assessment is a complicated subject, and there's plenty of debate in scientific literature about how best to go about it. But here we're just trying to understand the basics. So let's look at some coproducts in GREET, and that should help illustrate these terms and methods. We'll open the stationary process called dry mill ethanol production as an example. At the right in the output frames, we can see that the main output is ethanol. Below the main output, we can see there are two other outputs, DGS, which is an animal feed called distillers' grains and solubles, and electricity. There's 1 gallon of ethanol produced in this process, along with 2.556 kilograms of DGS. No electricity is produced in this case. We can edit the coproducts by right-clicking on one of the coproducts and selecting Edit Coproduct Method. A coproducts editor window pops up. If the displacement method is selected for a coproduct, we have to specify the resource that is being displaced, the source pathway for the resource, and the displacement ratio. There are drop-down menus for selecting the resource and source. The displacement ratio is the percentage that the related resource will be displaced by the coproduct. So if the displacement ratio is 78%, it means that a portion of the standard quantity equal to 78% of the coproduct quantity in this system will be saved. For example, if cattle are fed with 1 kilogram of DGS, we'll save 0.78 kilograms of corn from being produced elsewhere. We can add a displaced resource by clicking the Add Displacement button, and we can delete a displaced resource by clicking the X to the left of the resource. We can change the coproduct method by clicking Allocation. With this method, we need to choose an allocation type from the drop-down menu in the corner of the frame, and the options are mass, energy, market value, and volume. When we select the allocation option, a pop-up window appears telling us that there's no heating value specified for the DGS resource, so we can't use energy as an allocation basis. This is an important point because if we're allocating results to the various coproducts, we need to proportion them out on like terms, so units must be the same. The error message here says we can either specify a heating value for DGS if we want to choose the energy allocation method, or we can choose the mass allocation method, which is what we'll do, so go ahead and click OK. If there were a quantified electricity coproduct, we would need to specify an allocation type that can be applied to both the DGS and electricity. As it is, there isn't a common type for DGS and electricity since there's no heating value for the DGS resource and electricity has no mass, so we would have to either define a heating value for DGS to allocate by energy, or define market ratios for DGS and electricity and then allocate by market value. For now, we'll go to the allocation type drop-down menu and select mass. And some allocation factor calculations appear. The first shows us that the allocation factor will be calculated by dividing the mass of DGS by the combined mass of ethanol and DGS. The general equation will always be the mass of the selected coproduct divided by the combined mass of all other coproducts. The allocation factor for the ethanol product would be the mass of ethanol divided by the combined mass of ethanol and DGS. Beneath the first equation, we see the actual mass values inserted into the calculation, and below that we see the allocation factor, 0.461, so about 46% of the energy consumption and emissions burden will be allocated to DGS based on mass. A quick note, it's possible in GREET to have quite a few coproducts resulting from one process, and you can choose the displacement method for some and allocation for others. Just know that energy and emissions totals for the process are decreased through the displacing coproducts first. Then the remaining energy and emissions are allocated to those coproducts using allocation. Now let's see how results are affected when using different coproduct methods for a process. We're going to view 3 similar processes with different treatments for coproducts. The first process is called soy oil extracted from soybeans. The main output here is soy oil, and there's a coproduct called soy meal. Opening the coproducts editor reveals that the treatment method for soy meal is allocation, and the type is energy, and the allocation factor is 57%. Next, we'll open soy oil extracted from soybeans unallocated. This process is the same as the previous one except that there's no soy meal coproduct. Finally, we'll look at a process called soy oil extracted from soybeans with displaced coproduct. There is the soy meal coproduct, but this time the treatment method is displacement. The displaced resource is soybeans, and the displacement ratio is 1.2. This is a default value in this version of GREET based on nutritional value of the soy meal, since that coproduct is used as animal feed. Now, I previously copied results just for these processes into an Excel spreadsheet. The first outlined column shows results for the process with no coproduct. The next column is for the allocated coproduct, and the last column is for the displacing coproduct. The process that omitted soy meal as a coproduct had higher emissions and energy consumption for every category except VOCs. The cells highlighted in yellow show the values that had the greatest decrease from the first process. So we can see that factoring in a coproduct with either treatment method will decrease emissions and energy consumption for this process. And we can also see that neither method uniformly decreases energy and emissions over another, because in some categories allocation is lower and in others displacement is lower. The emissions and energy inputs affected by coproduct treatment will depend on the resource and its upstream impacts, and the quantity of change will depend on the allocation factor or the displacement ratio. This has been a relatively long explanation for a feature in GREET, and it's been a little more complex than other topics we've covered so far. The topic of coproduct treatment is important to understand when doing life cycle assessment, and after you grasp the concept, employing it in the GREET model is actually pretty simple. Stay tuned for more videos, and thanks for watching.